Okay, this video is going to go over the basics of setting up equations from word problems. Okay, so I'm going to go through a bunch of steps and then we're going to apply that to just a few problems here. Step one is what I like to call define your variable. So that means you're going to choose which letter you're using as your variable. You can use X every single time. I tend to try to use a letter that's kind of appropriate to what it's representing, but it's your choice. Okay, remember lowercase letters. Try to avoid O's and L's because they look like zeros and ones. After you choose what letter you're going to use, you are going to state what that variable represents and be as specific as possible. So for example, if we're talking about populations of a town, like P would be population in 1999, as opposed to just P equals population. Okay, that's what I mean by just be as specific as possible. Give a little bit more detail than maybe you originally were going to. And how do you know what that variable is going to be? This is the easy part. A word problem is going to ask you to find something. Okay, so that part that you don't know that it's asking you to find, that's what your variable is going to represent. Okay, now step two is write your equation. So you're going to look for other numbers in the problem that might need to be included. Sometimes there might be some extra information in there, so you do have to kind of be wary that you're not necessarily going to use everything. Figure out what numbers are going to go with your variable and decide what operations you need to do. Now, a lot of times you're going to say, Mrs. Prondy, I can just, solve this question. Why do I need it to set up an equation here? Because that's not the skill we're working on right now. But what is nice is if you know what, when you are looking at a question, you're like, to figure out this answer, I would, subtract and then divide. That means in your equation, okay, you're going to need some addition and some multiplication because when you're going through the process of solving an equation, we use those inverse operations. So if you know what operations you would need to do to actually figure out the answer, use that to your advantage and make sure the opposite operations are what's actually included in your equation. Now, this one is super duper important because this is what I see a lot of. Okay, your variable is never going to be alone on one side of the equation. Okay, if that's the case, you're solving the question essentially. Okay, you're not setting up an equation to represent the scenario. So it should never say X equals and blah, 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 blah with a bunch of numbers. That X has to kind of be incorporated in on one of the sides of the equation. If you have a total or a difference, that usually goes by itself. The problem is not every question will have a total or a difference. But if you do, that's okay, one side of your equal sign. And also the words per, each, and every are usually going to mean multiplication, which means this is a number that's often going to be the coefficient of your variable. So that being said, let's look at a couple questions. For each of these, we're going to read the question real quick. We're going to define our variable. So choose our variable and say what it's going to represent. And then we're going to set up the equation. Okay, we're not solving anything here. So you spend $12.75 at the movie theater. You purchase a ticket and a container of popcorn for $4.25. How much does the movie ticket cost? So this is our question, which means that's what we're trying to figure out. So I'm going to say, T equals cost of ticket. Okay. I do see a total in this one. I'm spending $12.75 at the movie theater. So I'm going to throw that on one side of my equation. And that total is coming from the ticket and the popcorn. Well, the cost of the ticket, we don't know. That would be T. The popcorn, we do know that was $4.25. And those two things are going to be added together to get that total of $12.75. And that's our equation. This one happened to be a one-step equation. You do not need to throw any units in there, especially any dollar signs. You don't need to include that. Just include numbers, operations, and an equal sign. Okay, the next one is you are buying a drum set that costs $495. The music store lets you make a down payment. Okay, if you don't know what a down payment is, that's usually for pretty big purchases like a house or a car, where you give them some money and they let you, drive the car off the lot, or they let you live in the house, but you still have to make those payments. So down payment is just you kind of giving them some money, but you can pay the remaining costs in 3 equal monthly payments with no interest charged. You make a down payment of $150. how much is each monthly payment? Okay, so once again, let's look for the question to decide what our variable is representing. It says, how much is each monthly payment? So I'm going to say P equals amount of monthly payment. Monthly payment. There we go. Okay. Notice if I just said monthly payment, that's not specific enough. It could be, how many monthly payments? Okay. So here we're saying P is amount of your monthly payment. Okay. I do also have a total again. The drum set is costing $495. So I'm going to put my equals 495 over here. And now you're going to say, okay, what's being combined together to give me that total cost of my drum set? Here, it's going to be that down payment, that money you gave them at the store, and then those 3 monthly payments as well. Okay, so where I'm going to say, let's start with our $150. Okay, and then we have to add in those 3 monthly payments. Well, if it was just one of them, we would just say plus P. Okay, 150 plus P, but we have 3 of them. So if I want to know how much money I'm paying together in those 3 monthly payments, I would take 3 and multiply it by the amount of one of the payments. So 3P is representing the amount altogether of those 3 monthly payments. We add them together. 150 plus 3P equals 495. Okay, 3P, just going to note this, 3P plus 150 equaling 495. Also acceptable. You can put your 495 first. That's fine as well. So there's multiple answers you can give here, but notice we're not just saying P equals and putting a bunch of numbers on the other side. That P is built into this equation. Okay, and last one, Sally and Anna went shopping at Target. Sally bought a pair of jeans for $35 and 3 shirts. Anna bought a new book for $15 and 5 shirts. All the shirts cost the same amount. What is the cost of a shirt if Sally and Anna ended up spending the same amount of money? Okay, so looking here, what is the cost of a shirt? So we'll say S is cost of shirt. But this one is a little bit different because we don't have a total. But what we have is 2 friends who went shopping and they spent the same amount of money. So what's going to happen here is we're going to set this up in a way that Sally's expression for what she spent has to equal Anna's expression of what she spent. So Sally bought a pair of jeans for $35. That's just going to be a 35 because that has nothing to do with the cost of those shirts. But she bought 3 shirts. So we would add in 3 times S. Anna bought a book for $15 and bought 5 shirts. So we would take 5 times S for Anna. And now those 2 sides are going to equal each other. And that's our equation for that scenario. Okay, so this is one where our variable ended up being on both sides. In those cases, you're not going to have that total. Just write expressions for both things that you're comparing. And then usually the question is going to say, one, will they be equal? So you just set them equal to each other. Okay, I know this is not an easy skill. Okay, but we're going to practice this. Okay, and hopefully get pretty good at this. And we got this.